So we're going to be using our calculator just like we did yesterday with these ratios, and what you need to understand is how your scientific calculator works and what it does in terms of the sine, cosine, and tangent functions and its inverse functions. So I'm looking at a screenshot here of my iPhone, and I've got the sine, cosine, and tangent buttons that we see right here that we used yesterday. So that's where we want to focus right now. There's a couple things you need to make sure of. First, you're going to want to make sure that you're in degree mode. So you can see right here on the screen the DEG. Okay. That tells me I'm in degree mode. That's what I want to see. Now, if for some reason yours does not say DEG, it may say RAD, then that means you're in radian mode. Radian mode is something we use a little later. Right now we're going to focus on degrees. So make sure you're in degree mode. If you're not in degree mode, the way you fix it is right down here. This button right here, it would actually have had the RAD up at the top of the screen, and you would have seen DEG down here. And you could have just clicked on it and changed to degree mode. So we want to make sure we're in degree mode. And then once we've done that, in order to use the sine inverse, cosine inverse, and tan inverse functions, I have to hit the second button on my calculator. That's the button right here. Okay, so I hit that button, and that'll bring up some other options for me. So here's what it'll look like. Hit the second button, and now you see the sine inverse, cosine inverse, and tan inverse buttons are available. Now, the iPhone, or iPod, whichever you're using, is a standard scientific calculator. Most scientific calculators will work like this one does, and the difference here is when you're using a standard scientific calculator, you typically enter information backwards when you're doing your trig stuff. So what I mean is if I want to take the sine inverse of 0.5, what I'm actually going to have to do is enter the 0.5 first and then hit my sine inverse button. So I actually enter the value and then hit the operation. If I'm using a readout calculator, so different than the one you're looking at right now, a readout calculator, like a graphing calculator, whenever you type anything into it, it displays everything you've typed on the screen. So if you type 5 plus 8, you actually see 5 plus 8 written across the screen. The plus sign actually shows up on the screen. That's a readout calculator. Now, if you have one like that, then you can just type exactly as you see. So if I want to say sine inverse of 0.5, then I would hit my sine inverse button first. It would display on the screen, and then I would type my 0.5 and hit enter. And so you need to establish the difference. Do I have a readout calculator or do I have a standard scientific calculator? Standard scientific, you enter backwards. Readout, you enter forwards. So depending on which one you have will determine how you enter this information. So I've shown you a scientific calculator. Now I'll show you the readout from a readout calculator. So if I want to do cosine inverse of 0.87 here, on a readout calculator I would hit cosine inverse first and then enter the 0.87. So just like we see here. And here's how it would look in a readout calculator. And we see that our answer ends up being 29.54, which rounds up to 30 degrees. So this is what it looks like in a readout calculator, but remember, if you're using a standard scientific calculator, just like your iPod, then you actually have to enter the 0.87 first, and then hit your cosine inverse button, meaning hit second and cosine. So if I'm using the standard scientific calculator, for a sine inverse of 0.85, I'll enter the 0.85 first, hit my second button, and sine. And here I see that that's approximately 58 degrees. And the last one, tan inverse of 0.71. Again, I'm using a standard scientific calculator, enter the 0.71 first, and then hit second tan, and it will give me that my angle is approximately 35 degrees. So this is how we're going to use the calculator to help us find those degrees. Now what we're going to do is we're going to use that inside of a triangle. So let's take a look at a couple of examples. Here we want to find the unknown measures. Now there's 3 unknown measures in this picture. There are 2 angles that I don't know the measures of, and then there's one side, the length of ST, that I don't know. So first we'll find the length of ST by using the Pythagorean theorem. Since my hypotenuse RT is 5.7, I'll set that up as the C in my Pythagorean theorem. So RT squared is equal to RS squared plus ST squared. Plugging in those values and then solving for ST, excuse me, gets me that ST is approximately 2.74. Now finding the angles, what I'm going to do is start with the measure of angle R. Now you're going to have to use your SOHCAHTOA rules to help you set this up. So R, right up here in the upper right hand corner, when I look at it, I have to ask myself, what pieces of information, what sides do I have? Now remember, we have 3 sides. We have opposite, adjacent, and hypotenuse. Now opposite is the side that is not created by the angle. So angle R is made up of side SR and side TR. Those 2 sides make up that angle. The side that does not make up that angle is ST. So for angle R, ST is the opposite side, which means since that's not the information I have, I'm dealing with the adjacent and the hypotenuse. Pretty easy to tell the difference between those 2. The hypotenuse is always opposite the right angle, so 5.7 is the hypotenuse, and therefore 5 is the adjacent. So remember your SOHCAHTOA rules. If I'm dealing with adjacent and hypotenuse, try to write this, then we're dealing with the CAH part of this, of SOHCAHTOA. So you have cosine is adjacent over hypotenuse. So my setup here is going to be that the adjacent over the hypotenuse, 5 over 5.7. Well, in solving for R, I'm going to take the cosine inverse of R, meaning I'm going to take the cosine inverse of 5 over 5.7, which is right here. Plugging that into my calculator, again, standard scientific, you're going to want to do 5 divided by 5.7. A little trick here. When you do your 5 divided by 5.7, make sure you hit the enter or equal button first if you're using a standard scientific calculator, and get your new value before you hit second cosine. Okay? And then that'll give you approximately 29 degrees for the measure of angle R. Well, I don't have to go through the same process again to find the measure of angle T, because I know that R and T, being in a right triangle, have to be complementary angles. They're going to add up to 90. So if I know R is 29, I just subtract 29 from 90 to get the measure of angle T. That tells me the measure of angle T is 61 degrees. Okay, let's do another one. In this case, I'm actually given one angle and one side. So if I want to find the missing pieces here, then I can use that information and actually avoid having to have a trig function. Or I should say have an inverse trig function. In the setup here, if I look and I want to solve for EF, for example, from 58 degrees, I do not have my hypotenuse, obviously. So that means I'm dealing with opposite and adjacent, EF, ED. Which is which? Well, from 58 degrees at angle F, the side that does not make up angle F, the sides that do make it up are FE and FD. The side that does not make it up is ED, so ED is the opposite. Since we know FD is the hypotenuse, that makes EF the adjacent. So 14 is the opposite, EF is the adjacent. Now remember, under SOHCAHTOA, your tangent rule is opposite over adjacent, which means I'd have to put EF on the bottom. So a little trick, if you don't like dealing with your variable in the bottom of a fraction, is Since you know the 58 for angle F and you know E is 90 degrees, then you know D pretty easily. What do you add to 58 to get 90? Well, you add 32. So that means that angle D is 32. Well, using that information, and let's go ahead and write that in here as carefully as we can. Okay, so we have 32 degrees here. Now, using that, let's look at EF and 14 again. From 32's perspective, EF is the side that did not make up angle D. See, ED and FD made up angle D. So EF is now the opposite. And since FD is still the hypotenuse, the ED at 14 is the adjacent. So EF is the opposite, ED is the adjacent. So when I do the tangent of 32, it would be EF over ED, opposite over adjacent. Now, by doing that, I've put EF in the top. So when I do the, when I set this up, it makes EF much easier to solve for. So I found the 32 degrees. The tangent of 32 is EF over 14, as you can see right here. And so in order to solve for EF, all I end up having to do is multiply 3 by 14. 14 tangent of 32. All right, and then we can use the Pythagorean theorem to find the other side, df. Okay, Baldwin Street in New Zealand is the steepest street in the world, grade of 38%. And all this means whenever you see a grade listed on a street, it says for every 100 feet that you travel horizontally, you will increase, you will go up whatever that percent was in feet. So 38% means if I travel 100 feet horizontally, I will have risen 38 feet. So what I'm going to do is I'm going to change that to a fraction. Well, it's 38 over 100. So that is my, my fraction for my percent grade. So if I use that to help me draw a right triangle, I can see what's actually going on, and then I can use one of my trig functions to find the angle. So here's the triangle. So for 100 feet horizontal, I rose 38 feet. So what I'd like to know is, what's the actual angle that's being created here at A for my incline? Well, from A's perspective, I do not have the hypotenuse, because that would have been AC. So I have the opposite and the adjacent. The opposite being the 38 feet, because CB is the side that did not make up angle A. Angle A was made up by AC and AB. So 38 is the opposite, 100 is the adjacent. Tangent is opposite over adjacent from our SOHCAHTOA rules. So I would say the tangent of A is equal to 38 over 100. So in order to solve for A, I'll take the tan inverse. Remember, in order to solve for an angle, you have to take the inverse trig function. So the tan inverse of 38 over 100. Now again, remember, in the scientific calculator, 38 divided by 100, enter. Get that number first, and then hit your second tan button. And you'll see that you get approximately 21 degrees for the measure of angle A. So a 38% grade translates to a 21 degree incline. Okay, so what we have for you is another extra credit opportunity. Come to class with the missing pieces of information, the missing sides and the missing angles from these two pictures using your inverse trig functions.